and the after effects like floods and other aspects when the snow melted. So keeping this in mind, I thought it would be very interesting for the students to see how we can use seismological instruments for detection of catastrophic flow events in rivers with regional seismic networks. And I just retired on August 31st as the chief scientist. Now I moved on to the Department of Civil Engineering, IIT Madras, as professor of practice. This is a temporary thing, but I teach there, and I also do R&D with the eminent scientists and professors at that department. Now, the most important thing which happens, yes. What is this actually we are looking at? Water flow in rivers is governed by gravitational forces that drive downslope, especially the water which is flowing, and the forces due to frictional resistance at the riverbed and banks. So water flow in rivers is governed by the slope and the gravitational forces which drive the water downslope, and also the forces due to the frictional resistance at the riverbed. So that also inhibits the flow and cuts down the velocity, and as well as the banks. So it cannot spread all over because there is a topographical changes which happen, and the banks also act as impediments for the water flowing. Frictional forces at the riverbed are in turn majorly control the velocity flow and the flow depth and the rate of sediment transport. See, what is very important, we think when a flood happens, it is just the water which is running, but there are in the mountains, when it happens, it has huge boulders, it has deposition of sediments and so on and so forth, and the gravel which gets itself deposited at the riverbed, that also inhibits the flow due to the frictional drag which comes in. So the rivers generate ground vibrations over a wide range of frequencies, and that is how seismology had come into play. That may be due to particle collisions during sediment transport, waves at the free surface cavitation, and frictional flows due to turbulent water flow acting against the riverbed and bank. Because you will see many a times when there's a flood, 10 meters per second, 8 meters per second, at that velocities, the water flows at very high speeds. So this is the one which creates turbulent water flow with mixing with sediments and rocks and creating a lot of ground vibrations. The spectral signatures, that means when you take the spectrum of the seismogram is that which you record the ground motion, that is the displacement with respect to time. So the seismometry, what we use is a velocity seismometer, which has got a frequency range anywhere from 100 seconds to 50 hertz. That is the dynamic range, that is the frequency range at which we record. And the dynamic range is such that we can even nanometers of ground displacements can be picked up. And this is a very, very important aspect. And because we have state-of-art instrumentation with 24-bit digitizers, we can be picking up anywhere very small motion to a large motion of ground displacement. So the spectral signatures, if you take this seismogram, the time series, and take its spectrum, the signatures of turbulent flow induced, that is the turbulent flow spectral signature, and the bed load induced forces, that is the bed load and the water when it is flowing and the drag which is created at the riverbed are significant enough, and these two processes can be characterized independently using seismic records acquired at various distances from the river. And this is forming a very, very important component globally using this physics-based signatures to design early warning systems. And incidentally, which I am now going to show the results in the coming few minutes, is the culmination of a seismological network which is being operated by CSIR and GRI, that is National Geophysical Research Institute, Hyderabad, in Uttarakhand, had helped us to map the Dhauli-Ganga catastrophe which has happened in Chamoli district. Now, when you look at the physical model for seismic noise generation by turbulent flow in rivers, if you consider this as one grain or a boulder of a different size, there are two forces which are going to act on this. That is the average force resulting from the contribution of all stresses applied to this given grain is commonly described as a combination of the average drag force, that is the drag which is happening when the grain is being moved by the water, and the average lift force. So that means there is a buoyancy also and the particle moves up. So these are the two major forces and they are contributing to the stresses applying onto the grain, and thereby that is dictating the drag force as well as the bed load force and the velocity of the particles, in turn creating a chaotic situation of a turbulent flow and in the riverbed. So this is the first paper which appeared in Journal of Geophysical Research in 2014, where physics-based mathematically simulated equations were created to see why seismic noise is being recorded on the banks of the rivers by the seismometers, and how we can interpret in terms of a physical process of a flood or thereby other aspects which do follow when such catastrophic events happen. So if we now go to the Dhauli-Ganga flood which occurred, you all know, in the month of February. This occurred within the dense Uttarakhand network of 76 broadband stations which are being operated by the National Geophysical Research Institute, with an interstation spacing anywhere between 18 kilometers and an average sometimes less than 18 kilometers, that is plus or minus 7 kilometers. And this has been set up under the Focus Basic Research Project and the Mission Mode project of the Council of Scientific Industrial Research to look at the safety and the security of the vital installations, which this network was installed in 2018. And the beauty of this network is it not only has the velocity meters, which I talked about, the broadband seismometers, but also strengthened by another 35 accelerometers. In the event of a large earthquake happening, we would be recording the ground motion of the large earthquake without the seismic signal getting saturated, whereas in the velocity meters they do get saturated if the seismometers are in close proximity, even for a 6 magnitude earthquake. So this event which had happened in Dhauli-Ganga flood, it created a lot of material which had slipped steep north face of Ronti Peak. That was about 27 into this cubic meters into 106 cubic meters of rock and glacier ice collapsed from the steep north face of Ronti Peak. 80% was rock and 20% was ice. The signals were observed up to 100 kilometers, that the seismic signals, the carving, that is the sliding, and the impact on the riverbed signals which were created were observed up to 100 kilometers from the disaster. And this demonstrates the potential for these faraway monitoring stations which can be used for early warning. Why do I say so? The unfortunate part of this happened was quite a number of people lost their lives who were working on the hydropower plants, especially which are being constructed, and the sliding, and by the time it came and started striking these power plants, there was a time lapse of about 10 to 20 minutes. And this would have saved, if the warning would have been given, this could have saved these precious lives. So CSIR NGRA, in collaboration with the Geoforschung Zentrum Potsdam, this Geophysical Institute, we are now planning to have an early warning system using this network and further strengthening to now provide warning, early warning to flash floods or such glacial cave carvings, which is correctly beautifully demonstrated, which I will be showing in the following slides, how beautifully this network had helped in trying to understand the physics of the process as well as the velocity with which these debris flow had flown from point A to point B. The seismic signal of the rock slide impact phase 1 registered throughout the Uttarakhand network. That means both in Kumaon Himalayas and Garhwal Himalayas. Actually, this event happened in Garhwal Himalayas with a signal noise ratio about 10 dB in the frequency range of 1 to 2.5 hertz. This is a high frequency where 1 to 2.5 hertz, where these seismometers have the natural frequency of recording these frequencies. Hence, they provided a robust detection in picking up the signal. The impact was also clearly visible in the frequencies below 1 hertz and in the far field, for example, at stations which were located at more than between 600 kilometers to 1000 kilometers. And what are those? Kathmandu at 625, Islamabad at 725, and Kabul at 1090 kilometers. So that is the power, and you can imagine the amount of energy which was released when this material of 27 into 106 10 to the power of this 10 to the power of 6 cubic meters of rock which came and struck this. So where did this event happen? This happened in a place called Ronti Peak, where the actual glacier as well as rock sliding had happened. And this is where the Rishi Ganga power project, hydropower project is existing, and this is the Tapovan hydropower project which is existing. So these are all quite far away. I mean, far away in the sense they're far away from where the event had happened. And if you look at the pre and the post-event satellite pictures, the pre, that is in B and C and D, you can very clearly see that in the B there is this small crack which has begun and it is expanding. And in D, that is January 1, 10, that is 2021. This is the satellite imagery of February 5, 2021. And on February 10, 2021, you can clearly see that the entire glacier as well as a rock mass has slid, and which is about 500 meters in length. And if you can look, 20 meters of glacier ice, which is there, 180 meters into 550 meters is the rock, and it fell from 5,500 meters to about 5,000 meters. So there was a rock fall of 500 meters, and you can imagine what kind of impact it would have created because of this huge mass of material which slid and fell down on the ground. So to give more about a demonstration, the initial landslide, 26.9 cubic million meters of mass fell down, 80% of rock and 20% of ice. So it fell down. While falling, because of the heat which is being created while the sliding is happening, the fragmentation and the melting of ice starts. And once it hits the ground, so the run up onto the opposite slope does happen. And then the possible entrainment and injection of water from valley sediment starts. Splashing of mud and water begins. Entrainment and liquefaction of snow is happening. And the rock ice avalanche, all these have started forming at a given point of time. And then the water-rich front escapes as debris flows, and the deposition of solid material is entrenched. And then what happens? You have first hit the Rishi Ganga hydropower plant power project, and then the Tapovan hydropower project. So this is the flow direction. The gray ones are the rock debris. The violet ones, dots, filled in dots are the ice, and the filled in dots which are blue in color is water. So now you can imagine, so it is a combination or agglomeration of rock debris, ice and water, all flowing at jet speeds. So what you can see is that 5 different locations, they have mapped the trim lines and the velocities at which this water was flowing. This paper appeared in Science, cited which is by Sugar, and a lot of Indians are involved in it. And you can also see how much of rock and ice and everything started flowing. It started flowing at 60 meters per second, almost 50 meters per second velocity. By the time it comes to 0.4, that is P4, the velocity decreases to 10 meters per second. So it was coming at tremendous speed. And what you can see, the yellow one is the rock fraction. The rock fraction is the maximum. You have the ice fraction, which is very less, and the fluid fraction, which increases as you are moving away from the impact. That means you are taking the water and the fluid is being injected out and striking both the power plants with the debris which had happened. So this is what we can see, that the debris started flowing at great speeds. And if you would like to see these satellite imageries, this is the September 30, 2017. This is the Rontigad, this is the Rishi Ganga, and the Dauli Ganga comes from, sorry, from the other side. This is the February 19, 2021. You can see the deposition and the damming of the river had happened. And this is the Rishi Ganga, which is filled with debris and the rock mass on this. On February 1, 2017, the Tapovan hydropower site was under construction, and you can see how it looks like. And February 10, 2021, the entire Tapovan hydropower site has been deposited with debris and rock and other silt and other material. And this has become more or less a graveyard-like thing because of this catastrophic event which came ahead. These are the 76 stations which we are operating, and this is exactly where the 7th February avalanche or landslide happened. And when you look at the seismograms at the different stations which we have within the network in Uttarakhand, you can see very clearly that the event is recorded. But the biggest challenge what we had here was to isolate the signal of an earthquake, which was from Philippines, which started some time before. We needed to remove that signal, and we had to compare the spectral signatures at Hyderabad Broadband Seismic Station. And you can pretty well see that you only have surface waves with not much amplitude, but whereas in the station at Ranchi, that these surface waves are overladen with high frequency waves, which are very much coinciding with the impact and then the debris flow. And if you try to take this and filter the seismograms of the vertical components at 0.1 hertz, that at 10 seconds, this is Masuri, this is Karnaprayag, this is Devprayag, this is Triyugnarayan, this is Agasthamuni, this is Auli, and they have a host of stations. And Auli happened to be the closest to this event. So the major initiation of the process is very well picked up, the impact, followed by different flood flows which had happened are marked very clearly. Indeed, we could see 4 events which are very much seen on the seismograms. And this is the displacement seismogram which we had to pick that up, especially the fall of that 29 cubic million kilometers of material which fell onto the ground, about 500 meters. So we had to model for this and see how the detachment plane looks like. And we took the seismograms at Auli and GDM. This is the spectrogram of the Auli station, and the lower hemisphere projections of a single force focal sphere. That means the detachment force and the orientation of whether it is upward or downwards we wanted to see. And very clearly we can see the detachment happened in the downward plane, which is very clearly shown by the seismograms. The black represents the data displacement, and the filtered seismograms are between 0.08 to 0.15 hertz. And you can very clearly see how you have the river gauges, which is at Joshimath, yellow in color. The hydropower sites are plotted in green color, the Tapovan and the Rishi Ganga. The flow location at different timings are seen and synthesized and modeled, which we see those phases on the seismograms. And the seismic station location is this Auli. So this was about 25 kilometers away from where to the southeast of the Auli station where this event happened. And if you look at the probability spectral density function of the seismogram, you can very clearly see the rock slide. There is a high energy, which you can particularly see. The greater the red the color, the more the energy is, the power of the spectral energy is more. And then we have the, what do you call, the mass flow, which is happening. And then after 25 minutes, almost, or 15 to 20 minutes, you do have the flood passing by the station. And very clearly, this was for about 10 to 15 minutes of the flood was passing by the station. And you can see the frequency content of that flood was anywhere between 2 to 8 hertz, 2 to 8 hertz. So the mass flow, which you see, is almost all around 1 hertz to 8 hertz, but the flood is very strongly characterized anywhere between 2 hertz to 8 hertz. So this is what is very important when you try to look at and try to study this energy content of this rock mass which fell down and the flow. And this information which you can see at different stations, which we could pick up the phase 1, phase 2, phase 3 and phase 4 of the different phases where the flood and the debris was flowing, was very important for us now to envisage an early warning system being located in this region, so that using the seismic signals and the frequency content of the energy of this flood of this rock mass, we can now have an early warning system designed in this region. And we were also tracking the flow and the velocity at different locations based on the seismic stations which we have. So the rock slide almost all happened around 4:53, and then we started seeing how the flow front is happening. These are all snapshots where it's based on amplitude and distance method that gives you the velocity, where you can very clearly see how the flow front was moving. And by 5:16, we could see it reached quite a distance, and the flow front was mapped at 5:28 at this point. So the rock slide sources again and again, you can see the flow front, which from a different method we wanted to test and see what we are seeing is an artifact of modeling, or is it a real value which we are getting. And more or less, the blue symbols, what you see are the flow front locations which we have been obtained from the satellite imageries. And very clearly what the satellite imageries had shown, more or less our flow fronts, which we have seen from our seismic signals, is reaching at the same point of time what the satellite imageries have mapped. So, and far field rock slide detection, very important. This is the Philippines earthquake, which I said was a challenge for us to remove this energy, because it had almost all right from 10 seconds of seismic noise up to 2 hertz we do find, and very clearly it can be seen at Kathmandu station. And this is the entire rock slide energy which you can see basically from 1 hertz to 3 hertz. This is at Islamabad. There is a station called Nilor, and this data is available globally for anybody. And then you can also see the rock slide is very clearly seen, but with a different time shift in comparison to Kathmandu. And in the case of Kabul, though it is not as strong as Islamabad or Kathmandu, but you can see still the trace of this up to 1,000 kilometers. So this is the power spectral density, the power of the seismic energy, the amplitude spectrum, what you can try to get, and you try to study this. So conclusions are, at frequencies smaller than 0.1 hertz, the signal generated by the landslide is contaminated by an earlier 6.1 earthquake in the Philippines. So that is the reason why we had to take bandpass filtering greater than 0.1 hertz, which more or less we know the seismic frequencies due to such kind of river flood or the catastrophic event of glacial calving is more than 2 hertz. So that signal could be picked up. The landslide consisted of several sub-events seen as pulses in the recordings which I showed. The main pulse was preceded by a smaller one about 54 seconds earlier. It was followed by 4 pulses which could be traced at almost all the stations in the Uttarakhand. The pulses were generated at nearly the same location, and these pulses propagated at velocities at 3 kilometers per second. And the particle motion, that is very important. When you look at the seismogram, you have the P wave, you have the S wave. These are called the body waves. And then you have the Rayleigh waves and the Love waves, which are called the surface waves. So more or less, when we looked at the particle motion of these waves, they are elliptical retrograde, suggesting that they are valley waves which are generated because of the turbulent flow. When the material is flowing, the surface waves are created. The transverse and radial ground motions have similar amplitude. That a single vertical source will not be sufficient to model the observed seismograms. It will require a horizontal force as well. And exactly that is what I showed. You have to have a drag force as well as a lift force. And the satellite images show very clearly that 27.3 into 10 to the power of 6 cubic meters of landslide, which happened, involved a rock volume of this amount, which is 80% and 20% glacier, fell 1200 meters and gives a potential energy of 8 into 10 to the power of 21 ergs. So that is the reason why this potential energy, which is seen and converted into the kinetic, from kinetic energy to potential energy, we could see the radiated seismic energy of the main event, which is about 2.6 into 10 to the power of 15 ergs. That means entirely it has not been converted. So there is a lot of energy loss which has happened. And the magnitude of this could be described as a 3.2 magnitude event. But a 3.2 magnitude event, if you had in Uttarakhand as an earthquake source, you could not be recording that at Kabul or anything. But this being, though the magnitude is less, but this radiated energy which is released and during the water flow, all put together gives you a fantastic analysis that which we can use it for an early warning system. Hopefully in 2 to 3 years, CSR and GRI, Geoforschungszentrum, Potsdam will be strengthening this network, and an early warning system would be placed to forewarn people in the event of natural disasters like cloudburst, like glacial calving, like floods which are created over a period of time. And this would be forming a very, very important component for saving the future of the citizens of Uttarakhand and the Indian citizens especially, and the others who go there as tourists. Thank you very much. This is exactly what I have to speak. So if you have any questions, I am open to them.
Thank you, sir, for such a wonderful presentation. Dipali, do we have any question in Q&A?
Yes, so one question we have. So the question is, are the hydropower projects a boon or bane for the environment?
But the hydropower, are there hydropower projects?
Are boon or bane?
See, it's a Hobson's choice. You can't say which is it's 50-50. See, what is very important whenever a project of these sizes are built in, 3 or 4 aspects have to be considered. First, what is the environmental impact it is going to create? First of all. Second, what kind of hazards are going to impact on these hydropower projects? And indeed, this is what is very much required. Most of the time, what we try to see is the hydrological events, which are like rainfall and what could be the flood generated, what is this impact assessment is done, as well as the environmental impact assessment is done, and earthquake hazard assessment is done. But such kind of one-off-one events which are happening, that needs to be looked in. And this is much more increasing in the last few years or decades is because of the climate change. Glacial calving was not frequent as what you now try to see happening at these places or elsewhere globally. So we have to bear this in mind so that whenever a project is built in, especially in such tectonically disturbed areas, basically we are now in Himalaya, and tectonically disturbed areas, what is important is the climate change effect, because the tectonics drives you the weather systems. The tectonic also is responsible for the climate, and the climate change and its impact is very, very important to be looked at. So for every boon, there is a bane, but what ratio it is, one needs to see. So natural disasters, do happen and you can predict to a certain extent, but still we have not understood the nature, how it behaves, and what can happen at many times. So this is one thing which we all have to live, and we will be seeing these extreme events happening much more and affecting all of us.
Thank you, sir, for answering the question. The one last question is, after Chamoli flood, why Chardham Road project is still on or is in the spotlight?
After this event which I'm talking of, this flood, right?
Yes, sir,
Oh,
yes.
So, how do you find your ideal?
Pardon me? Hello? Somebody was speaking?
Maybe someone mic's got on, sir.
Okay, Rupali ji, please repeat the question.
Sir, question is, after Chamoli flood, why the Chardham project is still on or is in spotlight?
Chardham project is the road connectivity, right? That is a totally different thing. The flood is a totally different thing. So the project is, we have to continue. See, one thing we cannot say that roads cannot be built. Roads are very important for any economic development, and especially for a country whose security is very important, and we are sharing borders with the different countries. And how are you going to transport your troops? How are you going to transport all your other equipment, ammunition, and everything? See, for development, we need to have, but in a scientific way. This is very, very important. See, all what we are now today discussing of this workshop is not that you will have a hands-on experience of what it is. You are being exposed to what are the possibilities of disasters which we cannot envisage, and what are the methodologies and technologies which are involved. This is the focus which we are trying to look in. Very, very important is this. See, I'll give you a small example. Everybody gets afraid when the ground shakes. We do not know what it is magnitude. When a lightning happens, you know it is followed by a thunder, and the thunderbolt can be just right by the side of your house, and your doors and windows shake. But you're not afraid because you know what is the cause. The causative, until you do not know, the fear will linger upon us. So that is very important, and that is why I think thanks to NIDM for having this workshop for the university students. Thank you.
Thank you so much. We are done with the question and answer round. Thank you so much, sir, for joining and giving such a wonderful presentation on this topic. Thank you so much, sir. Thank you.
Thank you, sir. Thank you so much.
Thank you. Venkatesh ji, I have to travel, so please permit me to leave if you don't
Sure,
mind.
sure, sir. Please.
Thank you. Very kind.
Thank you, sir.
Very kind. Thank you, Haldar sir.
So after
Thank you,
this
sir.
lecture, we have the second lecture by another distinguished scientist, Dr. Anirudh Unyal, who is not only a scientist but also a science communicator. And I like his lectures very much because he uses a lot of visuals and graphs, and so he would be talking on the river bank erosion, very important topic. Previous speaker was talking about the frictional force due to turbulent water flow, but that is also causing the many inundation of villages across the river, such as Sharda. Just today in the newspaper, there's one image that the last village washed away from the banks of the Sharda river in one of the stretch. So I welcome Dr. Anirudh Unyal, and I request Dipali to a little bit read about his CV and introduce the speaker. Thank you.
Sure, sir. Thank you, sir. So, Dr. Anirudh Unyal is an earth scientist and is working in the field of geosciences and disaster management for last 28 years, and is presently head at Earth Resources Division and Remote Sensing Applications Center, UP Lucknow. Previously, he has served in Haryana Space Application Center and Disaster Management Center, Uttarakhand. Dr. Unyal has more than 70 research papers and articles in the publications of Springer, Taylor and Francis, Emerald, Current Science Association, etc., and in various international and national seminars and symposiums, and he has written 2 books for his credit. He has been conferred with many awards for his contribution to science, popular science writing, and science poetry. Dr. Unyal has been involved in landside studies in Himachal Pradesh, Uttarakhand, Darjeeling Hills, and Sikkim, and also been a member of NDMA task force for formulation of the National Landslide Risk Management Strategy. With these words, I invite Dr. Onyal to kindly take over the stage and please address our audience. Thank you, sir. Over to you, Dr. Onyal.
Thank you, Dipali ma'am. Thank you, Professor Venkatesh Dutta. Thank you, Haldar Saab. It's certainly a proud privilege to be a part of this training. And I thank BBAU and NIDM from the core of my heart for giving me an opportunity to be part of this training. Am I audible?
Yes, sir, you're audible.
So I am sharing my presentation. Are you able to see the presentation on the screen?
Yes, sir, we are able to see.
Visible, doctor.
Okay, thank you, sir. So today we shall be discussing how best we can apply remote sensing in assessing river bank erosion, bank line shift, and channel avulsion. Remote sensing is like collecting information about an object or phenomena or surface feature of Earth without coming into its physical contact. And then our eyes to some extent do the same thing, because we can see the objects or features with our eyes. Then the question rises, why remote sensing is required? Because our eyes or human eyes have certain limitations, and beyond those our eyes can't see. So remote sensing can see through those regions of electromagnetic spectrum through which our eyes can't see. So this is one of the biggest advantage, and like active remote sensing or radar sensing, it can be used to see even during night time. So this is one example on the screen, how remote sensing is being utilized for mapping rivers. And this is actually the passive remote sensing, what we are seeing on the screen, wherein the surface feature of Earth, they are being illuminated with sunlight, and some of the light is absorbed by the feature, some part of it is reflected, and it is reflected back to the sensor of the satellite. From there it is downloaded in the form of image, and this image is processed on the computers using different softwares which are called image processing softwares. And once we process it, then this is on the lower right side is the final output in the form of map. Now some of the remote sensing platforms can be seen on the screen. Can you see on the screen this heading platforms?
Yes, sir.
Thank you. So we have mainly three types of platforms. Our first category of platforms is aerial platform. So these are the oldest platforms probably, and it all began sometimes in the mid of 19th century with the invention of camera, wherein at that time some cameras used to be mounted as an innovative way on balloons to take images of few houses or or that of a playground. That was the time where remote sensing was in its infancy. It was during First World War, wherein the navigators with pilot started manually clicking the pics of enemy troops, their armor or their artillery regiments. Armor means their tank regiments, and their artillery regiments, their infantry. And by Second World War, the current colored photography was introduced, and automated aerial photography started, wherein the navigator was not required. So after Second World War, these aerial photographs, which were taken from aircrafts, they were used for flood management, for forest management, for land use mapping. And in the beginning of 70s, this satellite remote sensing also came into being with the launch of Landsat series by USA. So with satellite, with the introduction of satellite remote sensing, Earth's imaging was possible through a number of satellites. And at the same time, there is another platform, that is ground-based platform, wherein ground-based sensors, like if they are mounted on a tripod or on a vehicle, they are also used for mapping. Now, The latest of the remote sensing technologies is drone or UAV remote sensing. Where is UAV is unmanned aerial vehicle, or US it is also called, where unmanned aerial system. These systems are also being used nowadays as aerial platforms for taking images, and the drones have big advantage, huge advantage, because they can go into narrow lanes where there are multi-story buildings on the both sides. They can take images of rivers wherein they flow through gorges. So even for microgeomorphology, for imaging of the small features associated or landforms associated with the rivers, these drones can be used. And drone, the full form of drone is dynamic remotely operated navigation equipment drone. So now these were the platforms, and these are the two major types of satellites. There is another category of satellites. They are called defense satellites. I would not be discussing them. So on my left side is a geosynchronous satellite, which is placed at an orbit about 36,000 kilometers above the surface of Earth, and it varies in the weight between 2.5 tons to 4 tons. So its revolution of Earth is synchronized with the rotation of Earth. Means Earth completes one rotation about its axis in 24 hours, and this geostationary satellite also completes one revolution of Earth in about 24 hours. So it looks as if the satellite is stationary. Actually, it is not. But this satellite has wide applications. If we are watching a match from Dubai, One Day International, then its transponders are being used. So it is used for telecommunication. If we are ringing up to someone there in USA or in Japan, then its transponders are used. So this is again used for telecommunication. And when we see the images on Doordarshan in the evening, that thunderstorms are likely to occur in this part of India. So all those images, coarse images, they are taken from its sensors. So INSIS satellites are used for TV transmission, telecommunication, and weather forecasting. Then on my right side is remote sensing satellite. This satellite weighs around 1 ton or 1,000 kgs, and it is placed in an orbit of around 550 to 900 kilometers above the surface of Earth. It is polar sun synchronous satellite as well, because it is somehow synchronized with the illumination of Earth from the sun. So because these satellites are basically for passive remote sensing, and they more or less go from north to south, and 90 degree, except 85 degree north to 90 degree north, and 85 degrees south to 90 degrees south, entire Earth can be viewed through them. And they are able to complete one revolution of Earth in about 1.5 or about 100 minutes, 105 minutes. And they have excellent revisit capability. We can see the same area after interval of every 5 days. And if we can rotate their camera, we can see even at a lesser interval. So now India is a country which has largest number of remote sensing satellites. So we have that revisit capability, wherein we can see any area of our country within a span of maybe 5 days or even less than that. And I think this is an excellent tool for river mapping, for bank line shift mapping, for river channel level studies. Now, when we talk about channel migration or bank line shift of rivers, what it is all about. Rivers generally move in two ways, and they have three stages. When river flows through hill regions, it is in its early stage of evolution, that is called youthful stage, where it forms gorges, the valleys are narrow, the valley walls are steeper, the channel is more or less straight, except in the areas which is tectonically controlled. But when river enters from the hill regions to plain regions, the gradient changes and the flow, the velocity also decreases. So the river is not capable of carrying that sediment, and it somehow deposits it at the junction of hills and plains, and that is called the foot region of the hills or the Piedmont zone. So there we see alluvial fans, a number of alluvial fans. If we see Ganga plain, we can see a number of alluvial fans somewhere where Yamuna enters into the plain areas from Uttarakhand to parts of Himachal Pradesh and Uttarakhand. And then we can see alluvial fans in the western UP around Saharanpur, Roorkee, and even in Nazimabad, Pilibhit. So, and even up to Devariya, Balrampur region, and further ahead, Gandak fans we can see in UP and Bihar region, northeastern part of UP and northwestern part of Bihar. So then, in alluvial fan regions, the channels are braided, and there are a number of bars formed within. And once they enter from this alluvial fan region to the plain region, there the velocity of river further decreases, and this is how we can see these loops. They form a number of loops or bands which are called meanders. Now, this is the mature stage of the river wherein it is witnessing meandering. And once river reaches at its end stage, where it merges into the Bay of Bengal, Ganga and Ganga and its tributaries. So there you see, because master stream in Ganga is Ganga, all the rivers they are merging into Ganga, and finally it is merging into Bay of Bengal. So there it forms delta. So that is the end stage. So now this successive migration and channel erosion, it is a peculiar phenomena in the mature stage in all through Ganga plains, or in the largest perspective, Indo-Gangetic plain, which comprises Ganga plain in parts of Uttar Pradesh, Bihar and Bengal, Brahmaputra plains in parts of Assam and Bangladesh, and Indus plains, which are in parts of Punjab and Haryana. So the migration of river takes place in two ways. Number is successive migration. Every year the river is moving towards the convex side. So this movement is successive. It could be from few meters to few hundreds of meters a year. This is channel migration, what we are seeing on the left side. But then in channel migration, suddenly the sinuosity increases, and there is a stage when the channel becomes very sinus, and then suddenly it witnesses channel avulsion, where the sinuosity is high, the band is very sinus. Then during floods, the river acquires a straighter path. Those who are students or beginners in this field, I would just cite one example. You just throw a glass of water at your floor, and then you will see that if you throw it with a force, it will flow in a straighter line. So similar is the fate of rivers when there are floods. The water acquires shortest and straight path, and in that case, the channel avulsion takes place. This is a textbook example of channel avulsion, wherein the meandering has taken place, and then during floods, the river has acquired this shorter path. So it could witness channel avulsion somewhere here because it has become very sinus in this part. Here, remote sensing and GIS, these technologies prove to be excellent tools for monitoring it on a decadal scale. Where was river flowing some 10 years back or 20 years back or 30 years back, and where it is flowing today? And if there are floods, maybe if they were last year or before last year, so we can monitor them on a decadal scale or even on a scale of 2 years, 3 years, 4 years. We can monitor this channel avulsion as well as successive migration. Now I would be giving some examples of this mapping, monitoring of bank erosion, bank line shift. This is one textbook example wherein we can see that this is Ganga River near Prayagraj. This is Prayagraj, earlier called Allahabad. So Ganga River was somewhere here near Fajulapur Bridge way back in 1973. And by 1999, it has moved around 2 kilometers southwest direction, and this direction is shown with this red arrow. So this mapping has been possible using remote sensing technology. A satellite image of 99 was taken, and then the river channel was drawn. It is shown with the this particular color, and then again image of 1973 was taken, and the channel was drawn from that. It was superposed on GIS, and then we can see how much has been the change in a particular direction. This is another example wherein we are monitoring it between 1973 and 2012. And you see that this is around 2.5 kilometers southwesterly migration. What is its relevance? The relevance is that if we had constructed one bridge here, sometimes in 1973, that bridge would have remained here only, and the river would have migrated here. So in selection of suitable sites for civil engineering projects, whether they are barrages or bridges or alignments of expressways or railways in the proximity of rivers, we need to consider this, that those segments of the rivers which have witnessed minimum migration over past few years are the best sites for any barrage or bridge. Otherwise, the civil engineering project will go into rough weather. Now, this is the digital elevation model of the same area. And this digital elevation model gives us a detailed know-how about this river valley, which comprises active floodplain and old floodplain of Ganges. And you see, this is confluence of Ganga and Yamuna. This is Yamuna. Yamuna is more emphasized, more entrenched, confined within its banks, but Ganga is more or less witnessing more or less successive migration at places. So this is only because of the successive migration of Ganga that Allahabad or Prayagraj city is witnessing floods for past 5, 6, or 7 years. Now, this is a very important example of confluence dynamics. And this is probably one of the most dynamic confluences of our country. But one thing is certain, this is most dynamic confluence of Uttar Pradesh. This is Ganga confluence. It is in the central UP. It is in parts of Hardoi, Kannauj, Shahjahanpur districts. And here, again, remote sensing GIS technologies, they have proved to be excellent for monitoring it, for monitoring not only bank line shift, but also monitoring the channel evolution, where there has been sudden change in the channel. You see, this is the topo sheet, which was downloaded from USGSI, because there were no satellites during 1922 23. So some maybe 100 years old topo sheet. And you see the confluence was somewhere here at that time. And this confluence has moved to about 13 kilometers upstream. When we took the channels of 2012 through satellite images of that time, this came into light. That is what has happened. Because you see, there has been many of the small streams have been captured in this region, like Kunda River was captured. And now this is what we can see, that the confluence migration, so it has not only been bank line shift, it has been channel evolution. Bank line shift could be on the right bank or on the left bank. But when the entire channel is migrating either on its right side or left side or upstream, that is channel migration. And if it is suddenly migrating, then it is channel avulsion. And you see, the channel avulsion has been taking place every year during rainy season, particularly during high floods. And it is astonishing to witness that during the period of some 90 years or 9 decades, between 1923 to 2012, this avulsion has been of the order of around 13 kilometers upstream. And the result has been a number of villages, they have been wiped out, they are no more on the map. Hundreds of hectares land was eroded. There has been severe bank erosion, and still this this channel avulsion poses a threat to many more villages. One more important thing is there. This Hajira Bijapur Jagdishpur gas pipeline, it also passes from this area. So this pipeline is a very important pipeline which supplies gas from Pambe basin of Gujarat to Mathura refinery. Generally, the gas pipelines, they are placed below the surface of earth at a greater depth when they are below river bed, and at a shallower depth when there is no river above. So what is happening is that because of the migration of Ramganga river, particularly in this region, it poses a threat to of erosion to that gas pipeline as well. So river channel migration study sometimes helps us for disaster resilience or for making action plans for safeguarding our infrastructure, including our bridges, railway lines, and gas pipelines. Now, assessment of successive migration and channel avulsion through mapping and monitoring of earlier courses of rivers. So, you see, there are relic channels, means earlier parts of earlier courses of rivers. If we could map them and we could understand their peculiar pattern, their peculiar orientation, then we will be able to infer many things. We might be able to construct paleo drainages. We might be able to delineate the precise boundaries of active and old floodplains. And we can infer to some extent the future behavior of the rivers, their future pathways, their future tendencies to migrate in a particular direction, wherein they are going to threaten a particular settlement, industrial area, croplands, forested areas, or any other important sites. So the rally channels is a general terminology which is generally used by civil engineers, but geologists or geographers, they use like the terms like dry channels, they are rally channels. Abundant channels means where river was flowing some 10 or 20 years back. Then meander scars, they are semicircular, concentric in shape. And then meander scrolls are just old pathways of rivers which are successive one over the other. They indicate successive migration. Old meander is a very strong indicator of channel evolution in the past. And old meander and oxbow lake are more or less same in the shape. They are semicircular. The only difference is oxbow lake will be filled with the water. Old meander is generally not filled. And then the paleo channel is like when there are a number of old meanders, meander scars, making a peculiar pattern, curvy linear pattern, that is a paleo channel, which could be old pathway of a river. So if we can map all these, wherein we can use satellite image, we will be able to map channel migration. How? This is here. Now, this is a paleo channel. And this is Ghagra River, which is now named Saryu as well. It is a very important river of eastern UP, which witnesses floods almost every year. And its catchment includes many rivers which are emanating from Nepal. They are causing flood havocs in the eastern UP. Now you see, there are very small streams, and some of these streams, they are flowing parallel to it. They are called Yazoo streams. Yazoo streams are those streams which are following a master stream, and they are flowing through its active or old floodplains, and they are just flowing parallel or subparallel to master stream for a couple of kilometers, 2, 3, 4 kilometers. In rainy season, they become very dangerous when they are filled with water. They can wipe out anything. Then there are some other streams which are called misfits. You see that there is very little water into this channel, but the width of the channel is very large as compared to the part of the channel wherein the water is there. So in the past, it might have been a bigger river. So this is misfit, but it is paleo channel as well. So this is paleo channel of Ghagra River. It is flowing more or less parallel to the Ghagra River, and very small stream is flowing through it. And now you can see there are a number of like oxbow lakes. Some oxbow lakes are here. Some old meanders can also be seen through it. So when we are mapping these paleo channels, even oxbow lakes, old meanders, some meander scars, so we are able to reconstruct the earlier drainage pattern in this region. And here we can see, this is another image, this is merged image. This panchromatic, black and white and colored image is merged. Again, we can see these paleo channels. And I think remote sensing technology is the best tool available in the world to map paleo channels. Because if we stand by a paleo channel in the field, we can see it only up to 400, 500, 600 meters. But through remote sensing, we can see its entire length and width. We can map it. We can measure it. How much long is it? What is the width? Where there is sinuosity? So all these paleo channels, they can be mapped, and not only paleo channels, these indicators of successive migration, meander scars, they can also be mapped. This is how they look on satellite image. Paleo channels, old meanders or relic channels, and this is how they look in the field. In the field, you see sometimes they are filled with water. Very little water is there. And generally there is a prefix used for paleo channels. Bud Ghagra, Bud Ganga. Bud means old. So our ancestors were well aware of the fact that they are remnants of large rivers. And sometimes they are filled with water. With the due course of time, these relic channels are sometimes filled with the silt, and then they look like this. And sometimes they are filled with aquatic weeds, and some small patches or pockets of water will be there. Sometimes there will be grasses, but there will be luxuriant growth of grasses as compared to the surrounding because of the high moisture content. In the rainy season, they are filled with water. These relic channels are excellent sites for groundwater prospecting. If you put a dug well near them, if you put a tube well, the discharge will be very good. The water will be at a shallow depth, but at the same time, these relic channels of rivers or old courses, they are very bad sites for construction, for civil engineering construction, because they will be witnessing waterlogging every year. So any building constructed there will be submerged because of the waterlogging. And secondly, they comprise softer soils, all these paleo channels. And the softer soils are something where there is more shaking of due to earthquake waves. So the buildings constructed within these will be more prone to earthquakes as compared to the surroundings. So excellent sites for groundwater, but bad sites for construction are these relic channels. Now, mapping of bank line shift and channel elevation helps in paleo drainage reconstruction. We can reconstruct the entire paleo drainage of a region. We can demarcate the active and old floodplains of rivers. We can have many inputs for flood hazard and monitoring, mapping and monitoring, and some seismotectonic studies can also be carried out by using these inputs of earlier courses of rivers. This is paleo drainage reconstruction. We can see here that entire paleo drainage is being reconstructed. And we are not only able to construct the paleo drainage, earlier river systems, but also their floodplains to a great extent. They are then active floodplains. Then old and active floodplains of present day rivers. You see in yellow color, this is the active floodplain of a river. Again, active floodplain of another river. And with the orange color, we can see the old floodplain of the rivers. So, by mapping all these relic channels, paleo channels, old meanders, meander scarps, we can map these because there will be more frequency of these relic channels within the active floodplain, within the old floodplain. And further, we can also see the break in the slope to some extent, even on 2D images. On 3D images, it will be very, very clear. So there's slight break in the slope at the junction of active and old floodplain, again at the junction of older floodplain and older alluvium. Now here it is clearer. You can see active floodplain on satellite image. This is the junction of active and old floodplain, and within the active floodplain, these fluvial features, they are more frequent, they are more abundant, and even within the old floodplain, they are more abundant. And as we move on to the older alluvium, they are lesser in their occurrence. Now for flood mapping as well, we can use these inputs because by mapping the active and old floodplains of all the rivers, we can provide a very crucial input for flood hazard zonation studies. Because once we are carrying out the risk mapping, we can know the hazard, we can know the vulnerability through remote sensing by mapping all the settlements, all the industries, all the power supply lines. Power supply lines we can map through LIDAR and drones, not with satellite images. And all these this information will help us in knowing the vulnerability of our infrastructure. And hazard we can know through by mapping the flood-prone areas, and hazard to vulnerabilities to risk. So risk mapping can also be carried out. And how do we do these things is by getting inputs about ground from satellite images, space-based platforms, aerial platforms like aerial photographs, and more recently through drones. We can get information about hazard, elements at risk, buildings, habitations, and vulnerability. And then we can combine all these into GIS, and then it helps us in preparing flood hazard maps and then a decision support system. Now, seismotectonic studies, they can also be carried out using this information from these relic channels, because you see if the river, the floodplains of the rivers are broader at certain places, and if there are alluvial ridges on both the sides, they could be indicators of some of the lineaments, as can be seen in these images. And then this is how they look in the field. They are in the form of alluvial ridges, but all these are getting deteriorated with the passage of time because of the supply of soil from these areas to the other areas for construction. Now, anthropogenically induced bankline shift is also there. If you are like in this portion of Himalayas, some headrace tunnel is being constructed. So its waste material, it is being submerged into the disposed into the river channel. So it is resulting in the shift of the river channel, and that it is causing toe erosion on the other side. So digital elevation models based on the contour lines and satellite images, they can also help us assess exactly where the toe erosion is taking place, and is it because of natural phenomena or due to anthropogenic activity. Now, the decision support modules that we can create through GIS were in number of layers, whether they are base layers, elevation, geology, land use, and road infrastructure, river stream, and channel migration. All these inputs can be used for flood hazard zonation mapping. Now, an example that how bank line shifts or bank erosion channel reversion creates havoc. This is the example. You see, here vulnerability also has a role. The Kedarnath flood that took place in 2013, similar flood took place in 1882. But at that time, some 1, 2, 3, 4, 5, 6, 7, 8 to 9 huts were around Kedarnath temple. So the vulnerability was very low. I think a population of maybe 20, 30 might have been there. Pilgrims might have been there. But in 2013, we have around 100 lodges, restaurants in Kedarnath. So I think it was sad that a population of more than 10,000 was there, or maybe some, according to some sources, it was 30,000 people were there. So the vulnerability was very high. So because of the high vulnerability, there was more risk and the more damage was done. You see, this is the picture of Kedarnath in late 90s. Now there are available portals for getting information about rivers, about geomorphology, about different aspects of rivers. So they are rssub.org.in, where in our website it provides updated information about flood maps. We have a dedicated division of disaster management in our center. A disaster management cell is there. So that prepares maps about floods in Uttar Pradesh. These are available on this website. Then on one website of NRSC, again, we can have information about river geomorphology in any state of the India by clicking the name of the state. This is how we can get satellite images on one portal. I would end my this discussion by citing some lines of my poem, which is about geospatial techniques. And this poem was published in Vigyan Pragati. I have penned it myself. And I'm citing few lines of it, that how important remote sensing is. Because remote sensing, GIS, GPS, LIDAR, all these technologies are conjunctively called as geospatial technologies. So I am reciting the poem. मानव निर्मित उपग्रह हो या हो अंतरिक्ष यान, वायुयान हो या ड्रोन हो या गतिशील या बम लिडार, ये सभी देते धरती का ज्ञान विज्ञान और विस्तार आत्मसात कर सके यदि हम ये देते ज्ञान का भंडार। नगर हो या गांव हो या खनन से धरती पर बने घाव हो, खेत हो या खलिहान हो या घास के मैदान हो, तालाब नदी या पोखर या हो वन या वन्य धरोहर, भूदशा हो जल भरा हो या धरती का कटाव हो, खेती हर हो या उसर हो, दलदल हो या बंजर हो, हर प्रकार की भूमि के चित्र हमें मिल जाते हैं। उपग्रह चित्र, वायु चित्र पॉइंट क्लाउड कहलाते हैं। पॉइंट क्लाउड हमें लिडार से मिलते हैं। कंप्यूटर तकनीकों से विश्लेषित किए जाते हैं चित्र, जो जीआईएस है उसके लिए टर्म यूज हुआ है। कंप्यूटर तकनीकों या डिजिटल इमेज प्रोसेसिंग की बात कर रहे हैं। कंप्यूटर इमेज तकनीकों से विश्लेषित किए जाते हैं चित्र, अल्प समय में इन चित्रों से बन जाते हैं मानचित्र। भौगोलिक सूचना तंत्र से एकीकृत होते हैं मानचित्र, निर्णय सहायक तंत्र से संचित होते हैं मानचित्र। डिसीजन सपोर्ट सिस्टम भी इन मैप से हमको मिलता है। इन तकनीकों से त्रिविमीय मॉडल भी बन जाते हैं, मीन्स 3D मॉडल्स। इन तकनीकों से त्रिविमीय मॉडल भी बन जाते हैं जो पृथ्वी की ऊंची और गहरी सतह दर्शाते हैं। वास्तविक धरातल छोटे पैमाने पर दिखता है, पर मापन में यह सटीक दिखता है। मिल जाते अक्षांश देशांतर वैश्विक स्थिति उपग्रह प्रणाली से। ये ग्लोबल नेविगेशन सैटेलाइट सिस्टम की बात हो रही है। मिल जाते अक्षांश देशांतर वैश्विक स्थिति उपग्रह प्रणाली से सटीक भौगोलिक स्थिति दिखती इस जीएनएसएस बलशाली से। कहीं जियोस्पेशियल या भूस्थानिक इन तकनीकों को, या कहीं अद्भुत विज्ञान की इन तरकीबों को। थैंक यू सो मच, थैंक्स अ लॉट।
Thank you, Dr. Anirudh, for giving a very thought-provoking and knowledge-induced, rather, context of migrating behavior of rivers, which are very much characteristics of the tropical rivers of South Asia. All these rivers which come suddenly from the Himalayan systems and enter the plain, then entire energy gets dissipated and they try to migrate change path, and there's a famous case of Kosi River mega fan, as you were talking about the Ganga Ramganga confluence. But the Kosi mega fan, you see the Kosi River has shifted eastward by more than 150 kilometers, I think 180 or something, I don't remember exact figure, but close to 200 kilometers the river has shifted. So such a massive, migration of rivers are happening. So thank you so much. If there are any question, I would request Dipali to read out.
Sure, sir. So one question is, which type of satellite data is most suitable for flood hazard mapping?
Flood hazard mapping, actually, it is not about the type of satellite data. It is about satellite, multi-rate satellite data. We can use optical data, but then if there is cloud cover, then optical data will have some problem. But if we use satellite data of a number of years, like at an interval of 5 years or maybe 10 years, and then we can also use the topo sheets of century-old topo sheets of 1911, 14 or 20 survey. So we can have a comparative assessment on a century scale. So if you want to use satellite data, we can use any satellite data, LISRO satellite image, LIS3 satellite image of 2021. Then of all those years, in which years river has witnessed peak floods. So we need to have some literature survey that in which particular years the river had peak floods, and satellite data of those years can be taken. If we are taking entire catchment of Ganga, then suddenly we have to take a coarse resolution data, maybe VIPS. If we are taking a very small river like Gomti River or maybe Rapti River, then we shall use LIS4 or LIS3 satellite image. So it depends. If you are taking a very big river which has a length of hundreds of kilometers, we need to use coarse resolution data. Where scene size is bigger and resolution is less. If we are working on a very small river, which is of maybe 50 kilometers length, 100, 200 kilometers length, then we can use LIS3 data or LIS4 data.
Okay, sir. Thank you, sir, for answering. Another question is, how can we mitigate meandering?
Mitigate meandering. This is, I think, Yaksh Prasna, I will say. Yaksh Prasna, which was asked by Yaksha to Pandavas. So, you see, there are certain things which are beyond the control of human beings. As I told in the beginning, and which is something taught to us, I think, in the graduation level, that once river enter in the plain areas, they are in mature stage of cycle of erosion, the velocity is less, so they start meandering. And wherein they form loops on the either side of their banks. So we cannot stop meandering, but if there is a critical project adjacent to a river, then we have to do like digging of channel, and alternate channel is carved out there to just deviate the flow of the water. But I think the best thing is that we keep our critical infrastructure away from the meandering channels. We should not construct any power plant, thermal power plant, nuclear power plant, or any other critical facilities or satellite town in the proximity of a meandering channel, because ultimately then we will have to take a number of measures for taming the river. So I think the meandering channel need to be viewed in the perspective of the planning of new infrastructure, and we should keep away from that site for any critical civil engineering project.
Yes, sir. So thank you. We are done with our question and answer round. Thank you so much, sir, for joining and sparing your valuable time and sharing the past
It's my
knowledge.
privilege.
Thank you so
Thank
much, sir.
you. Thank you, Dr. Arjun.
Thank you, sir.
So we move to our next distinguished panelist and speaker, Dr. A.L. Haldarji, who is now working as a consultant at NIDM, and the topic is also very much relevant to the entire training program on river hazards, that is flood, disaster, and resilience. Resilience word is very important because the more resilient you are, the less vulnerable you would be to the climatic changes and other shocks. So we are trying to develop resilience, the resilient society, the resilient ecosystem, and the resilient economy also. So may I request Dipali to speak few words about Dr. A.L. Haldarji.
Sure. Thank you. Dr. Amrit Lal Haldar, he obtained his post-graduation degree in exploration geophysics from Indian Institute of Technology, Kharagpur in 1985. He completed his PhD degree from Vikram University, Ujjain, Madhya Pradesh in the year 2003, which I had pursued during the job. After passing out of IIT Kharagpur, he served as Danish International Development served in Danish International Project, Government of Orissa, Bhubaneswar as geophysicist from 1985 to 1988. He performed massive groundwater exploration of freshwater in the coastal area of Odisha. Thereafter, he joined Remote Sensing Application Center, UP Lucknow, as Scientist SC and elevated up to Scientist SG. Worked on geophysical exploration for groundwater on hard rock area of Bundelkhand as well as alluvial area of entire Uttar Pradesh, remote sensing, GIS, and DGPS, LiDAR, and bathymetry. 37 projects is sponsored by state, central government, internationally also were completed during the tenure of the Remote Sensing Application Center. He was appointed as Director of Remote Sensing Application Center, Uttar Pradesh for a duration of 2 years and got superannuated in March 2020. Presently, as Professor Datta mentioned, he is working as a consultant at the Flood Monitoring Cell at National Institute of Disaster Management, Delhi. To the credit, he had 67 technical papers in international and national general and symposium, and he visited several countries like France, Italy, and Switzerland for the technical program. So, with these words, I invite Dr. Amritlal Haldar to kindly take over the stage. Over to you, sir.
Okay, thank you, Deepali. Thank you very much for your appreciation and the introduction to the audience. Now I can share it. Deepali, is it visible?
Yes, sir, it is visible. Kindly put on slideshow.
Yes,
Yes, sir.
I hope it is in that slideshow. So, the today's topic, as Professor Dr. Paul, it's not disaster, not disaster. Just 1 second, please. This is the subject. That slide has come. Just 1 second, please. Now some different slide has come. Some other topics. So please.
Dear participants, we will begin shortly. Just some technical glitches there. He's about to share his presentation. Kindly wait.
See. Yes, I hope Deepali you are able,
Yes, sir, your screen is visible, sir.
and the screen is visible, and my voice is also audible.
So your voice is audible, but it is cracking a little bit.
Okay. Okay, I'll try to put some space on that. Now, the topic is it is the focus on that special for resilience. And initially, I'm showing some lot of examples that what happens in this 2021 and 2020. Glimpses will be given, say, for the last few years. So you know that in this 2021, how the flood fury is given losses and distress to the people. Say, from the month of February, what we have learned, what we have listened from Professor Datta and Dr. Sri Nagesh or NGRI, that has happened in this Uttarakhand, say, first week of February. Thereafter, flood is coming one by one. After that, during the month of May, cyclone gas has given the tremendous shock and tremendous problem and a lot of destruction in Odisha and Bengal, especially in Bengal, that a lot of things which have been submerged. Of course, the death is less because warning from government side and scientists have developed early warning how especially for the cyclone it's very effective and losses have been reduced, but still been submerged, especially the tourist spot in Bengal is did not reach. That was their speed was more than near about 100 kilometers per hour, and the waves was being reaching, say, just coconut trees are abundant in that coastal belt. Near the top of the coconut trees, it reaches more than 7 to 8 meters somewhere it is touching. And all the roads is being flooded and these purposes and these that area has been submerged. That you know that rainfall was there in Odisha, near Bhadrak, but still in that eastern coast from Bhadrak to Bangladesh has been affected, especially in Bengal, that is in West Midnapur, East Midnapur, and this Tipur Pargana and Nadia. Hooghly also, that has been suffered, and the flood has taken place since that point. After that also, several low depressions are created in Bengal. Continuously floods are there, not only in Bengal. So in the month of this October, it has reached to the Kerala also. And you know that in this October, that even the flood was there in Uttarakhand also. So in India, you know that potential area is 329 million hectares. Now, more than 40 million hectares are sold. Causes of concern, greatest damages, and showing year by year it is increasing. It means the trend is increasing. Now, earlier, within the average annual flood damage during last year at present was 5,000 crore or more. Compare in earlier what has taken that in 50 years in average, that is per year it was 2,000 crore. It means that how the flood, the quantum and frequency are increased and how it is giving the problem, especially in India. Of course, it is not restricted in India, it is in other countries also there. In India, more than 27, out of 27 states and 6 union territories, more than, say, 18 states are flood prone and floods are taking time to time. So during 2021, as I told you, that several predecessors already highlighted, especially in London National Park, where 83 bodies and 36 human body parts were recovered out of rest of the lot of people are missing, especially in the park land. In that intensive chapter space and major disaster was told that maybe the causes of the ice avalanche and large rock spaces that were the causes. You see the glimpse of that cyclone was the focus center, and it had landfall in the Andhra, eastern coast of Odisha. And the rural states, especially northeastern of India, eastern and northern, northwestern, of course, now this year, the northeastern states are not that much in flood fury, but it is there in south. In comparing to last year, the south, it is, but still it is there, especially in the month of October. And however, the program is within this year, these are the states which have been affected, especially Uttarakhand, West Bengal, Maharashtra, and eastern part of Uttar Pradesh, as Professor Dr. one village is within flushed out. Kerala and Maharashtra, what is happening in Mumbai, and especially from the flash plates taking place in Mumbai and Kerala also, and it's getting problem day by day, and frequency is increasing. In this month, October 21, 15th, incessant rain was there. Residents were cut off from various parts of the coastal state. Was what worst affected area was Kottayam, Idukki, where received in one day, that is 164 millimeter, that is 305 millimeter, Idukki, Kottayam, and Idukki in one day. Now, how impact will be given in that area, especially in the south and for the flood? That would matters. As per incident, the 7th morning, heavy and trigger and landslide has taken place. There also a lot of casualty happened. Of course, in Kerala, these are the last starting from say 2018. 2018 was very common. 2019 and 20 also. And finally, 21, the month of October in Kerala, this landslide taken place. And in this year, 26 people have already died. Of course, it may be more, but so far, it's pleasant news. In Assam, you know, what the aim, especially in the left-hand side, that is floods, is very close, especially from the Bhutan. There are a lot of 56 rivers flowing from the Himalaya to the western part of the Assam. This side, it is coming, especially from the Bhutan, the river there. Because the Unitarian means that a lot of rainfall is there. It is adding to India. That is in Assam. It is why the flood is adding. Similarly, to the right-hand side, that is the eastern part, by the Brahmaputra and some main is Brahmaputra and its tributaries. So other rivers, Devan, Bani, Suvarnasri, which are big landscape in the eastern part of Assam, and it is creating the flood in India also. So these are the main factors that why Assam is very much flood year by year. Significant flood taking place during the 2003, 8, 12, and 14 and 15. Each year, one or other conditions there in Assam is very common. But these are the years where significant flood taking place and a lot of casualty. Here, you might be knowing what happened during the 2008. See River, what he was highlighting, predecessors, and 2008, what was the havoc was the specific Kosi River, and now Professor Dr. Bikul, that is the shifting, especially from the migration river to more than 100 kilometers. And if you see that, now they under the no images are there, but still you can correlate with the 5 more than 100 kilometers where shifted that river. So, what a geologic situation and geometric features of importance there is here you see. Now, these rivers, this Kosi, it is coming from the mountain, it is coming from the metal, and the activities are there. There are 20 in the last, during 2020, that was the plan was there, and the statistics say that 27 categories are there, and more than 5,50,000 which are evacuated. a lot of other casualties. In Bihar, like 2008, some other years are also there. You can see that 2013, severe flood taken place, 2000, 2002, and 2016. And if you see the gist of the floods in the year, one by one, the major floods have been tabulated in Assam in 2000, 2003. And besides, you can see the reason, mostly reasons and the heavy rainfall, casualties are there. So in 2000, it was 121 people there, it's reported. And in 2015, obviously, it was less. And how much people population is being affected, that is there in this property values also. In Uttarakhand, 2013, nearly it was nobody knows because a lot of persons are missing. It could be placed. So far, more than 4,000 people casualty are there. And lots of people, what I feel, standard are and mostly they are missing still. Kerala, we have seen, as I told you, 2018, 2019, that landslide taking place, and 2019, more than 121 persons have died. So far, at that time, it was 7 persons are missing. Which also you can see, Bengal, these are the gist of that. Only past 20 years, what is a significant past taking place in India. Kerala, the scenario in 2019, and this was the one part of the flood. Kerala, the product were affected, shifted, landslide taking place, all are due to the first flood means the heavy rain and suddenly. And during June, if you see in Kerala, that was June, the rainfall was there 649 millimeter. Actual rainfall was supposed to be that average rainfall was 749 millimeter. Whereas in the month of June, it was taken place 649. And similarly, that month, July, it was at 726. And that was happened between 1st to 19th. Again, in the month of August, it was late. It means that is 1649 millimeter rainfall taken place in the Kerala that was in 2018 against the total rainfall was say 2346. It means the practical departure region, if you see, that was in the month of June, was 15%, and 19th, past 19th August, the departure was 164%. As it was rainfall was at 287, whereas it was normal rainfall 27, whereas actually it was taken place 70. So it reached that 164% degree. So this has given the impact to that region as a landslide and flood. So what I told you about the Munna is very sensitive place, especially for the landslide, and that is the beautiful place nowadays for the tea. That is the tea very active and is there. This is very good. Originally, it was the same very sensitive for the landslide. In Mumbai, you know that in 2020 there was severe floods. Causes are low, that nowadays that this competition is going on, and all the floods made, and all the damages are being stopped and construction are going on. These were the indirect effect of the direct effect you can see of the flood. No damages are flood. Even the mountains are there. Even the flood. What was impounded within the mountain. So that's why it takes 2 days to receive the water in that city. So it was common in Mumbai, some other city also. And all these are happening because that basically you can say the climate change. So this climate change is one of the major factors of this flash flood. The statistics in 2018, 10th July. So these are the cities are called. Here is in a day. July, 80 millimeter rainfall was there. That was in Gurgaon. Similarly, 280 millimeter. It means that how the flood intensity and that rainfall intensity has been increased day by now onwards, 2005 onwards, it is there. You see that scenario in the area of public and the people carried with the platform can rescue, manage the people, save the people from mistaken. So a lot of things are depending on climate change. You know, this emission gas, emission gas, and this carbon dioxide, and this cutting of trees. These are the major causes for increasing the temperature in the atmosphere day by day. So already some panel is there for reducing the global warming. By this 2100 year, we should reduce, if not 2 degrees Celsius, just 1 or 1.5 degrees Celsius, or else it will be facing the severe challenge. Say all the pressure will be in the melting. If not, really some part it happens when the sea level will increase. Beside the sea, a lot of people, residents are there, who are responsible to produce a lot of foods for India. They will lost for that, a lot of light will be lost because that they are residing dwelling in that area, so it will be totally submerged, and this rising temperature is prevent the disasters, especially for the poor people, day by day, and especially in these disasters that mostly victimized. And not only poor, but other persons, they are also victim this disaster. Now, by some means, it means that we can reduce the carbon dioxide emission far over 20 that planning for that. We have to reduce, or else severe loss that all the phenomenon, adverse phenomenon is going to be happening. Is the global warming. So in 2016 in Bihar, what happened? That was the less rainfall. It means the red color because the minus. It means in that year, mostly the northern part of Bihar, not in the central part, because what was. Similarly, immediately after that is 2017, you see the spice blue color, that rain, excess rainfall. So people, that too much less rain and excess rain, both sorrows and boom, not boom, reasonable condition for the. So they thought during 2017 that it may happen the same repetition of 2016, which is not, but no, it's not brought. I mean, the rainfall has given the sorrow, it brings again destruction in the. So this was the scenario in 2017. I'm not very good so that already has been brought that in 2013, he was also brought on the Kedarnath phenomena was happening in Godavari Glacier that was burst, and it was the sealed water, the glacier melted water that has given fury in that region. Of course, that temple to save, but in that region, that standard tourists, they have been washed out in that area. So that was great loss in that. The initial part to that, quite few years left was there. But we can say that day by day, increasing the thing and the issues that the farming issues in Uttarakhand, especially in the slope, because there is a very much seismic zone, zone. We have to think how the land to be managed, where to be planted. The rivers, in that region, the rivers are coming from that hill. That is getting blocked due to the landslide debris. That has to remove time to time. or else it will cause the spilling. So what is the origin in 2013 at flood means that tragedy. You know, there was cyclic circulation. It was developed low pressure area in the Bay of Bengal. And it moves towards westerly, rapidly intensified the moisture, and the moisture supply was from Bay of Bengal, Arabian Sea also. And it has added the western disturbance. It has caused a phenomena. It means that flash flood taking place in that Trokoyad, Chamoli, and a lot of total 7 districts were affected. District. The Chumoli glacier that was in the height of 3,800 meters. These floods that affect the Chumoli glacier, it has been cascaded and it has affected the flood. Not only Uttarakhand, Himachal Pradesh and part of Nepal and other places that acute stoppage between the cyclic circulation that was affected, it has caused the flash flood in this region. Now, you know the Tamil Nadu, what happened in 2015, that was the cause of the again flash flood. The havocs are there. I'm not going to details of that. Even the some scenarios are there. In Chennai, that was received 1,049 millimeters. It was 41 inches rainfall in one day. That was the 15th of it. That was caused. That was the end of that southwest monsoon, the beginning of the northeast monsoon. In the transition zone, both are added the fuel. Fuel means that moisture, rainfall was taking place, and it was pretty severe scenario phenomena in the history of India. See the statistics of rainfall, Chennai, scenario in place. You know what is flood? That is a high flow which overtakes the natural channel provided for the runoff. Flood generally takes place in the area which is dry. Suddenly, the water comes from nearby area or from the rain. What's happened? It means that in the dry area where it is submerging and that with great quantity, then flood takes place. The flood is any relatively high stream flood naturally, and what of the natural artificial banks? You know that flood is not a purely physical notion, but a geomorphological and water management. Causes, you should know, high intentional rainfall, the major cause, meandering and process of river. What Dr. Real was telling, is meandering, and it's meandering. Not if the rivers are meandering, especially in eastern UP, that happens. All the rivers, maximum rivers are meandering. In that places it is taking place. And the meandering, even sometimes it was happening. Erosion was taking place, and even the boundaries, somewhere that's in the river side, one side, the Mr. After the flood, it was changing the location. And similarly, for the channel gradient, if the sudden change is there, the flood takes place, and different river valley and channels, natural river valley and channels, the flood takes place. But from the natural causes or anthropogenic causes are also there. You can see building activity and eventual urbanization. The eventual urbanization is giving the major causes. So what is happening in Mumbai, what is happening in other cities, say Kolkata, and even in Delhi also. Of course, but this year in Delhi, more than 1,500 millimeter, 1,501 millimeter rainfall takes place. It means it's a record in the 121 years. That was the rainfall recorded in subdivision. And of course, Delhi is managed. It was not flooded, well managed. These are all the things. But of course, waterlogs are there. These are happening due to this waterlog and this flooding, especially metro cities, is happening due to anthropogenic causes. Here, no deforestation is there, land use are changes, channel manipulation through diversion of channels. These are there. So, due to this thing that it is happening in the metros. So, these are the different stages of flood. So, when the flood takes place, then we have to think of the relief, thereafter rehabilitation, then reconstruction of the area, mitigation, and the before flood, you have to be preparedness. And when the disaster happened, after that, relief and other things will be there. So this was the scenario of the flood. So I'm not going, like Dr. Uniyal told about the remote sensing and GIS, what we'll do, the channel evaluation, the same things, same phenomena in the same way, we can use the remote sensing and GIS as a tool, how to prepare the flood hazard zone. And you know that in the very interior places that where people cannot go immediately, that remote sensing technology, it gives the immense information and it can guide how the people, how where the relief to be reached, which place the NDRF or SDRF people should reach. The remote sensing technology and the separate data that can give immediate information. It's remote sensing because the synaptic coverage and real-time information is flood in areas, river process channels, and speed channels are mapping nicely, precisely, real-time, without any bias. So this was optical satellite data, one area. So what you should do with free flood? You should prepare the inventory, floodplain assessment. You should obviously, if you are doing floodplain assessment, it means that you should be free for the so that no flood takes place. But unfortunately, we are not in that condition. That's why it is happening. And also, we should think for the flood routing. If flood routing is already there, then have the days together, even months together, flood water will be stacked up. During the pre-field flood region, we should think of the flood routing. Flood evaluation map, we should prepare. Flood mitigation map also, we should prepare. During flood, what we will do? Flood inundation, flood extent, you have to map because at that time, during the flood, you cannot get the optical data, you have to depend on the data. And obviously, India is very much independent to have this type of data. But not only plan for other purposes also. You have to know the status of critical facilities so that you can transfer the public area to India. It could be peacefully, they can be shifted and they will be safe. And you have to assess the route of transportation. Assess the property damages, assessment of stuff. These are the things. So you know that during 1998 in UP, what happened in Gorakhpur and Maharajganj? Say in the month of August, say 2nd August, the flood starts. During the incessant rain, more than 7 big dams, reservoirs have been broken. Flood water been impounded. If that was due to the less of proper drainage, it means it was so congested, it could not, the flood water could not be shifted or could not be managed properly. That's why what I'm telling you, flood routing should be there, all the drainage congestion to be removed so that this type of things, months together, it was there, the water in the Gorakhpur. So this was the radar set data. In this Rapti and Khabra River, you see this was the and Maharajganj is there, Rapti, and Keodia district is there, river is there. So this totally black color to see the how much quantity of area it was being inundated. In this river also we have that. This was the sequential monitoring. It means you see the green color, that was inundation. The green color, that was inundation in the Thar. And red color, that was on the 38th. Of course, the green color was there, red, but to show to mark it, the contest it was shown. You see that from 3rd August, 38th August, how much and property of all the crops being damaged, how much loss was there. This was the village boundary that Maharajganj and Gorakhpur district. So how many villages were inundated, you can count. That was the due to the facility of GIS. So I'm not going to this. So these are the things which are needed to prepare the database for the flood so that we can manage during flood all the things. Now, what you will do and what you will not, you should not do rules and follow rules. Rules, you should think the safety first, yourself and for the family and for them, for the public, others. Take care while walking through the shallow water, and you should only go to the walk in the shallow water, and that will during that time, all the electricity appliances and gas supply should be stopped and even not here also. You should not do what should not be done. Don't try to walk right through the flood water. You should not flood water, wherever it is there. You should not think anything except that you should see that. Don't go up across the bridge because the bridges are so fragile. And it may go to the new one also, but you still take a chance to cross the because if you cross, never swim in this fast flowing water, avoid contact with the flood water as it may be. Precautionary measure you should take before and during flood. Your family members should know the safe route to the nearest shelter. They should be aware. If not, in the local media, radio, TV, they should put it on. They should follow. Still, that guys nowadays, that much only what we want that one is developed, guide the people in that area. SDRA, and other persons that is in place. Emergency kit should be with you. Try to keep some dry food, water, and gas. These are the things the building not should be at least somehow safe. Your home surroundings should be filled with water so that some sandbags should be ready. Seal your entry point so that your plant water does not go inside. Do not allow the children, women, pregnant women remain empty stomach. So that will cause some other harm. Now you know the snakes are very much abundant in the flood, so you should be avoid to for the snake bites. So these are the certain things. Now I should tell about the road safety. While driving, you should go very, very slow and fast gear. You should put the headlights on so that others could be spotted. And if some mishappening there, steer it, and I will take care, then give hints of that. Similarly, that keep a hammer close to the driver so that if any other things is happening, then the headrest of the car, of the vehicle, damaged and can go. So that's why a hammer is needed. The vehicle during that time. So these are the how we prepare the flood risk tourist map.
Sorry to interrupt, sir.
Yes.
We are running out of time, sir. So kindly
Just
please.
I'll finish it in only 2-3 minutes. So when discussion was there in the flood risk tourist mapping, the settlement data, the other ancillary data, say geopolitical boundary, road network, these are being repaired. Because GIS, you can prepare the flood risk donation for the purpose of the administrative people. So in satellite, there are a lot of limitations and also these are there. Now, to come to the prevention, we know that prevention is better than cure. It means that preparedness should be taken place. The prevention is the activity to reduce flood risk, and it will promote appropriate land use, agriculture, land management, forest management. These are the things you should be able to measure in these ways. You should be aware to inform local residents of flood risk and appropriate action in the event of emergency is there. So how the flood risk could be reduced? You have to introduce better flood warning system that is very required. India improve day by day. Modify your homes and business in stand of the floods. Construct buildings above flood levels. Tackle climate change. Increasing spending of flood defenses. And you should protect wetlands because they are also to some extent giving relief to the flood, to absorb, to store in the water. Now, how certain bodies to reduce the flood damage? Clean out to its troughs and downspouts. It does not take much water to produce localized flooding. For this, big dams and reservoirs can help. Expensive furnishing and reinforce your roof. It means that you have to take precaution on your own building. Purchase, you should be aware. You should be taken the flood insurance also. So now, what is the flood resilience? But it is a term that has become more commonly used and generally means the damages are minimized during the flood times. It means that you have to do such a way, like a certain technology, that flood damages could be minimized. So that is the resilience. And what is resilience? Protection flood to improve a home's protection from flood loss. This is the program offers resilience protection and flood event. This optional coverages allows the homemakers to repair structure with flood resistant material and such as water resistant drywall. So these are the things for the resilience of the same and for the district and for the state. How can flood resilience be increased? The individual property owners can take their own steps to increase their flood resilience. Building owners can employ such methods as increasing the building elevation. A building should be elevated day by day, and constructing these levees. These levees are repaired so that some flood protection takes place and getting water diversion as a plan taken. Similarly, these are the things, these are the 3 points are there for building resilience. You can read out. Now, to minimize the floods, there are certain measures are there, that is a structural measure and non-structural measure. Especially structural measure, the reservoirs. So, West Bengal, that Commodus helicopters dam is there. It is a quite set up in British period, and it is continuing day by day. This year, West Bengal, there was rainfall was there, but still it is Commodus corporation has reservoirs, and they are managing, they are absorbing, and during the peak flood is there. So they are storing the reservoirs, and after some time they are releasing, putting in reservoirs should not last. Because same thing is here in Ukaidar, in Gujarat it is there. And detention basin outfalls should be there, because wherever the depressions are there, the detention basins be made in those areas. Give off or eradicate the flood in those areas. Sometimes the embankments, embankments are there, that should be extended. UP, that ministry is very much aware of that. Embankments, so they are very much vigilant, and not a single embankment should be broken in such a way. They are vigilant that they are taking care. And also, this channelization of river, a lot of talks are there. Channelization can minimize, and that boom somewhere is the bill somewhere. The channelization, I heard that it is stagnant is there, that it will create a problem, but and with no, I will show one figure. See. So you see, this is the generalization of it. You see the left hand side, how this one is the channels. Now, if you channelize in one way, that it not be minimized and it will pass nicely. Similar, other concept there, but it's a time positive and going. And certain non-structured approach. These are the India is highlighting because it will reduce the, you cannot stop the rainfall, what is happening. But this non-structured approach can minimize the flood. That is the flood plain zoning we should do, flood forecasting that should be done, and this forecasting should be transmitted in time. And this reservoir operation we should maintain, integrated reservoir operation, we should integrated way reservoir operation should be done. And safety emergency action plan. Yesterday, that NRC Sri Lakshmi, he has highlighted the emergency, some action plan for emergency action plan. He knows a lot of things for that. And the use of this space technology, the Erosion and GIS, other technology, is very much useful for the non-structural. It can minimize it, can mitigate the problem. Similarly, for the adherence of coastal geodesignation. Now that's all from my side. Now we should think for the resilience, especially for building the area, and all those drainage should be thoroughly should be managed so that no obstruction, no debris should be there in the hill. If no, at least it should be moderate, and so that flood water, other water will pass through. We should think on the global warming. Then in that we can be, India can be resilient. Other things to be mitigated. Now, this is, thank you very much for your peaceful hearing. But Dipali, you can go.
Thank you, sir, for your wonderful lecture, for giving the background of various types of floods and cause and how we could prepare the flood zoning map. So if there are any questions, Deepali could read out.
Sure, sir. There is one question. What is the reason of recent flash flood in metro city like Delhi, Gurgaon, and Mumbai, and how can we mitigate this?
See that these flash floods are the causes. You know that this warming, this global warming is happening. Now, average temperature, it is raising 0.5 degrees centigrade, only 0.5 degree. Then what is happening? That extra moisture within the cloud, it will be 3% more. Now, each day by day, the temperature is increasing. Obviously, the global warming is there. Now, we see the 3% increase in this moisture within the cloud. Now, that will give definitely some impact. Especially, it is giving everywhere the rain, but the flash flood, especially in the Fury, in those areas, with the concretization and the abandon of the in this floodplain, and say the very a lot of in dull case of the channel, that flood water is not getting reduced. Even those boundary walls, they are not allowing the flood this water to flow smoothly. That is another thing. But of course, the flood routing, it means some routing, the routing should be there. So that slowly the flood water should reach to the sea. So these are the causes. That's why this flood threats is giving but nobody knows how it could be stopped flash flood. Because we cannot stop the global warming drastically. But we can do this plantation. That is also another cause. And we should also mitigate carbon dioxide emission. These are the things if you do, then definitely to some extent it will be reduced. In metro cities and other places also.
Okay, sir. So thank you so much. As we are running out of time, we will just take that question only. Rest of the questions, I ask the participants if they have any questions, they can post to us. So we will try to answer them and forward you via email. Thank you so much, sir.
Thank you so much, Dr. Haldar, for your interesting talk. So we had a very fruitful day today, 3 lectures, starting from earthquake and the seismic hazards to the bank erosion and the flood zone mapping. So I look forward to seeing you all tomorrow, which is the last day of the training program. We'll have three very informative lectures. So see you tomorrow. Thank you so much to everyone, including our Professor Surya Prakash ji, Dr. Haldar ji, and all the team from NIDM for hosting this. Thank you so much.
Thank you, Professor,
sir.
for moderating the session. I request the participants to kindly be there for the last day of our training session, that is tomorrow, and please use the same link from which you have been joining us from past 2 days, including today and the last day. So thank you so much. Stay positive, stay safe. Thank you.
Thank you, Dr. Saab. Nicely conducting the session. And of course, little time is more, but I can geometrical, but at least that it's attendees should be benefited. You have taken
Right.
care, but I hope that everything will improve. Tomorrow again we will meet at the same time.
Sure, sir, sure. Thank you so much.
Thank you, everyone. And
Thanks.
in case if anything is missed by the participants, these sessions are on YouTube also. You can go and check out the YouTube videos for the same. Thank you so much. Thank you.